Okay, I'm back. Got cut off before. So what I wanted to explain is why there's an x here. So if you have ln e to the x, because ln and e cancel out, you get an x. So just a little quick review from pre-calc. Okay, so what I want to do is work on these last two problems for differential equations where you have where you're finding a particular solution. So we've kind of already done this before. These are just going to be maybe a little bit more challenging to integrate, maybe a little bit more algebra, maybe some trig identities, just a little bit more grip to it, okay? So feel free to try it, pause and play as you need to. Okay, so what I'm going to start with on this one is cross multiplying as usual. So I'm going to get dy times 1 and then just throw a dx over here. I want my y's to be together, so I'm going to divide both sides by negative y. I'm going to rewrite this and take the integral, negative 1 over y dy, and take the integral of x plus 1 dx. Okay, we had talked about this before, the 1 over y is just ln, but because it's negative, I'm saying negative ln y. This is easy, just basic power rule stuff. Don't forget your plus c. Now, what I need to do is, because I have that particular solution, I've got an x and I've got a y value. I'm going to plug in that point. So negative ln 4, 0 squared plus 0 plus c. ln 4. Well, this is all just going to cancel out, so that means your c has to be negative ln 4. Take that, plug it back into the original one here. So we're going to have negative ln y plus all that stuff. Oh, and I think I made a mistake. Yep, I forgot to do my power rule there. Okay, so hopefully you caught that. And let's see, plus x minus ln 4. All right, now that I have the correct integration, just some algebra, just some pre-calc, playing around with this. If I have a negative here, I'm going to get rid of that and make all of these other things change signs. So I've got ln y, I'm going to make this positive, make this negative, I'm going to change this to a positive, and I'm going to make this negative. So I'm going to erase my plus sign. And then just like before, because I want to get y by itself, I'm going to use this as like a power. So I'm going to do e on both sides. That's going to give me y. And I'm going to kind of skip some steps here because I'm running out of room. I'm going to explain what I'm doing. So I'm raising this to a power, and then I'm also going to split this up just like I did before, because whenever you have addition, remember you can change it to multiplication with the same base. So I'm going to keep my x stuff together, but then I'm going to split that apart. And, ooh, this is nice because e to the ln 4 is just 4. So I can actually rewrite this as 4e to the negative x squared. That's what's fun. I mean, I guess I'm using that word loosely with math, but I think that's what's neat about math is that sometimes, I don't know where I'm going. I just know these algebraic properties, and splitting that up, I know that's something I can do. I didn't know what was going to happen, but I got very excited when it did happen because it makes it look a lot prettier. That this canceled out. So sometimes you just have to kind of try something and see what happens, and if it doesn't work out, well, try something else. As long as you know it's true, it's okay to do it. Okay. One more. If you want to pause it and try it, that would be great. I will give you a hint and tell you that your integral is going to be one of your trigonometric, what am I looking for? Antiderivatives. Okay, so keep an eye out for that. If you're like, oh, I don't know how to deal with this, it's because it's a trig one. So if you have to look that back up, or just kind of, you'll see when you get there. Okay, so if you want to pause it, go ahead. Okay, so the first thing I'm going to do is cross multiply as always. I'm going to get my y's on the same side, so I'm going to divide by y squared over, or divide by y squared plus 1. I don't like seeing dy on the top. I prefer to see it on the side, but either one's fine. And that leaves me with just 1 dx. So take the integral on both sides. This is what I was talking about. Hopefully this looks familiar. 1 over something squared plus 1, that's tangent, or the arcsine of arctan. So bringing that guy back. And so now I have this point 1, 1. I'm going to plug that in. And I love doing the inverse tangent of 1. I think you probably do too, because it's easy. You won't even have to look at the unit circle for it. It's pi over 4. And then I'm going to subtract 1 on both sides. And that's my c value. Kind of gross. You could type it on the calculator and get a decimal, but just leave it like that, okay? Don't stress out yourself. This is what the inverse tan is equal to. So, oh no, I need to fix this. I was trying to be lazy, but I don't think it's going to work. So let me get my c value. And so I've got c, so I'm going to go back to this and plug in my c for that. So inverse tan. Okay. Now I've got the inverse tan equal to that. So what I can do to get y by itself is multiply both sides by tangent. Then that inverse tan, that tan will cancel. So this will become a y, but then I'm going to have to do tangent of all of this. But you are done. You don't have to simplify anything there. And that is it. Okay, so I hope fields and separable equations and differential equations are all coming back to you. If you need more practice, let me know. And good luck.